Topic is called stoichiometry. It deals with the numerical relationships in chemical equations. So a balanced chemical reaction equation shows two things. The first thing is what reactants combine to form what products in a reaction. The second is the numerical relationships between the reactants and products. That means the quantity of reactants that are used and the quantity of products that are formed. So these numerical relationships is what we call reaction stoichiometry. Here we can see the example of sodium hydroxide reacting with sulfuric acid to give sodium sulfate and water. Now sodium hydroxide has to be given the coefficient 2 because in the product we have Na2SO4 which has got 2 sodium. So this becomes 2NaOH plus H2SO4 giving sodium sulfate Na2SO4 and 2 molecules of water. Now from this equation we can get this equation and all chemical balanced equations, we can get what are called mole ratios. By mole ratios, we mean the ratio between any two substances in a balanced chemical reaction. So the ratio between sodium hydroxide here and sulfuric acid here is based on the coefficient of sodium hydroxide, which is 2, and sulfuric acid, which is 1. So the mole ratio between sodium hydroxide and sulfuric acid is 2:1. Now, in this equation, for example, we can write the relationship between sodium hydroxide and sulfuric acid, sodium hydroxide and sodium sulfate, sodium sulfate and sulfuric acid, and so on. You can write the relationship, the mole ratio between any two substances in a balanced chemical equation. Now, if we consider the relationship between sodium hydroxide and sodium sulfate, we can write the relationship in the above balanced chemical equation as the mole ratio 2 moles of sodium hydroxide is to 1 mole of sodium sulfate. This means that 2 moles of sodium hydroxide will react to give 1 mole of sodium sulfate in this equation. Now using this ratio, which is called mole ratio, we can calculate how many moles of sodium hydroxide are required to produce, let us say, 10 moles of sodium sulfate. Because we know here 2 moles will produce 1 mole. So if you want to get 10 moles, we have to make 20 moles of sodium hydroxide. Then only we can get 10 moles of sodium sulfate and vice versa. So in general, mole ratios can be used to convert between the amounts of any two substances involved in a chemical reaction. Now, in order to properly calculate, we also need to know the relationships between moles and mass in grams and Avogadro's number. This is because even though we can define moles by the ratio of the coefficients, it is not possible to take moles or count moles. We have to weigh out or we have to measure mass. So we should know the relationship between moles and mass in grams and Avogadro's number. Therefore, the relationships are as below. 1 mole of a substance, its molar mass will be equal to its molar mass in grams. For example, 1 mole of water weighs 18 grams. That is because water has a molar mass of 18. But 1 mole of carbon dioxide, that has the weight 44 grams because the molar mass of carbon dioxide is 44. It's not 18. So the mass of 1 mole of any substance is not the same. They are different, and that depends upon the molar mass of that particular substance. However, we have another value which makes all of them equal, that is the count. That means 1 mole of a substance is equal to 6.023 into 10 raised to 23 particles of that substance. That is like saying 1 dozen is equal to 12. You can say 1 dozen apples, it's 12. 1 dozen oranges, it's 12. In the same way, 1 mole apples is 6.023 into 10 raised to 23 apples. It's just a count. So the mole of any substance, it's not just water or carbon dioxide or any of them separately or individually. All of them, the mole of one substance is 6.023 into 10 raised to 23 molecules or particles of that particular substance. For example, 1 mole of water contains 6.023 into 10 raised to 23 molecules of water. 1 mole of carbon dioxide also contains 6.023 into 10 raised to 23 molecules of carbon dioxide. Now this number 6.023 into 10 raised to 23, this is called Avogadro's number. So from these three relationships, we can also understand one more relationship, that is 6.0233 into 10 raised to 23 particles of carbon dioxide will have a weight of 44 grams, whereas 6.023 into 10 raised to 23 particles or molecules of water will have only 18 grams. Okay, so the number of particles is the same for 1 mole of any substance, but the mass of 1 mole will be different, and so the mass of this particular number of the particles will be also different. Here is an example how to do a stoichiometric problem based on the same mole ratios that we saw. So the question is, how many grams of sodium hydroxide are required to fully consume 3.10 grams of sulfuric acid? Now, the answer can be done in different a number of steps. First, you have to write the balanced equation, of course. So this same equation that we have written earlier, the same equation we'll be using. And so step 1, write the balanced chemical equation. It is 2NaOH plus H2SO4 gives Na2SO4 plus 2H2O. In the second step, you have to write the mole ratio of the species that you are concerned with calculating. For example, here we are dealing with sodium hydroxide and sulfuric acid. So we write the mole ratio between these two. So according to the coefficient, the mole ratio will be 2 moles of sodium hydroxide is to 1 mole of sulfuric acid. Step 3 is to find the moles of sulfuric acid in 3.10 gram of sulfuric acid, because we cannot directly calculate mass from mass. We have to go from gram or mass to moles. Then using the mole ratio, you have to go to the moles of the other reactant, and then from that moles you have to go to the mass of that reactant. So this is the way we have to do. So first we have to convert 3.10 gram of sulfuric acid to moles of sulfuric acid by dividing by its molecular mass. So its molecular mass is 98.08. Sulfuric acid, the molecular mass is 98.08. Okay. So we find the moles of sulfuric acid in 3.10 grams of sulfuric acid by 3.10 times 1 mole of sulfuric acid divided by 98.08 grams of sulfuric acid. See, 1 mole by the mass. So mass times 1 mole divided by mass means the grams will cancel and the unit that you get will be moles. So when you divide these, you get 3.16 into 10 raised to minus 2 moles. This is the number of moles of sulfuric acid in this particular gram, in this particular mass of sulfuric acid. Step 4. Now you have the moles of sulfuric acid. Use the mole ratio to get the moles of sodium hydroxide required. You do this by multiplying the number of moles of sulfuric acid that you just got with the mole ratio. So 3.16 into 10 raised to minus 2. 3.16 into 10 raised to minus 2 moles of sulfuric acid is what you have. Therefore, you require times 2 moles of sodium hydroxide divided by 1 mole of sulfuric acid, because the mole ratio is 2:1. So when you multiply this, you get 6.32 into 10 raised to minus 2 moles of sodium hydroxide. So now you found out the moles of sodium hydroxide that you require to exactly neutralize 3.10 gram of sulfuric acid. Now you have to convert this number of moles to the mass of sodium hydroxide. And how do you do that? You do that by multiplying the moles of sodium hydroxide with the molar mass of sodium hydroxide. So the molar mass of sodium hydroxide is 40 grams. Therefore, 6.32 into 10 raised to minus 2 moles of sodium hydroxide multiplied by 40 grams of sodium hydroxide divided by 1 mole of sodium hydroxide, and you get 2.53 grams of sodium hydroxide. So you require the mass of sodium hydroxide required to fully consume sulfuric acid is 2.53 grams. So this is a simple way in which you make use of mole ratios to convert the quantity of one reactant or relate the quantity of one reactant to another reactant in the same equation. Thank you.